Now the third part of data manipulation operations is shift operations. So shift, by the name itself you'll get it, right? Shift is nothing but shifting the bits of the register. Generally we load the operand into the register and then we perform these operations on the register itself. And in most of the cases we are going to design the registers in such a way that shift operation is going to be easy. So you know how does the shift work? I mean, in shift registers we have already seen it. There are certain kind of connections between the flip-flops. Therefore, at hardware level itself, we have the facility to give some signals and then implement this easily. Okay, so let's see what they actually mean. I mean to say the meaning of the operations. Later we shall see the implementation also. Okay, not now. Now let's see the meaning of each of them. So first one is logical shift right. So shift right means we have to shift to the right. And what do I mean by logical? So observe these words. Logical is written and then arithmetic is written. So logical shift right, logical shift left, arithmetic shift left, arithmetic shift right, rotate right, rotate left, rotate right through carry, rotate left through carry. Okay, just observe this difference between these are important. Logical shift right, let us say we have a register like this. In this register, assume that we have this 8-bit register and we have some data. Now if I apply logical shift right, then I have to shift all the bits to one position to the right. Got it? One position to the right. As a consequence, what happens is the rightmost bit will fall off. Therefore, when I shift one position rightmost bit, it will fall off, and this bit will enter here, this bit will enter here, like that. Okay, so what happens is, see this bit will fall off. Okay, this bit will come here, 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 and now the leftmost bit, there is nothing there, so we are going to fill it with 0. Got it? So this is called right shift, logical right shift. So we are going to shift all the bits to one position right, and in the most significant bit we are going to fill 0, right? So that is called shift right. Okay, and the rightmost bit we are going to lose. Got it? Now what are the various parameters that we can pass to this operation is how many times you want to shift it to the right. If you say this is nothing but shifting one time, if the operation is given in such a way that we have to shift 2 times, then what happens is after shifting 1 time we get this. Again from here we have to shift 1 time, which means this one will fall off, and again everything has to be moved right. Understood that? Now similarly, left shift will work the exact opposite way, which means we'll shift all the bits to the left. Okay, this is right and this is left. Now this one is shifted left, which means this one will fall off and this one will move here and this one will move here. Therefore, if you look at the shift left, how does it look like is this will fall off, so this one will come here, which means the 0 will come here, and then 1 will come here, and then the next one will come here, 0 will come here, 1 will come here, 1 will come here, 0 will come here, and finally there is nothing at the end, therefore 0 will be appended. Got it? So in case of right shift, 0 is appended at the most significant bit. In case of left shift, 0 is appended at the least significant bit. Got it? So this is called as logical left shift, logical right shift. You have to also see how many times they are asking us to shift. Depending on that you will get the answer, right? And the next one is shift arithmetic shift right. So now let's take the same number 1 0 1 1 0 1 1 0, right? So this is some number. Now what do I mean by arithmetic is we have to consider that the number is a 2's complement number, and we have to conserve the sign when we are shifting right. So arithmetic right shift means, just remember this, we have to consider this as the I'll just take the register. Now you'll understand it. Now you have to consider it as if it is a 2's complement number, and we should not change the sign at all, which means this particular bit will not change at all. So when you are trying to do this arithmetic right shift, the sign bit will never change. Sign bit is going to be as it is, and everything else is going to be shifted. Got it? So what do I mean by that? So from here, this one is going to be shifted here, 0. This one is going to be shifted here. This one is going to be shifted here. This one is going to be shifted here. 1 is going to come here, 1 is going to come here, and the 0 is going to fall off. Now what are we going to fill this with? This one is going to be filled with this sign bit itself, which means sign bit is going to be filled here, but this time sign bit even stays here. Got it? So since this is a bit different one, let's see one more example on this. Let us assume that we have a 8-bit register like this. 1 2 3 4 5 6 7 8. Number is 0 1 0 0 1 1 0 1. Let's say some number is like this. Okay, and now I want to perform arithmetic right shift. As I told you, when I'm doing this arithmetic right shift, the sign bit does not change, but all the remaining bits will move one position to the right, which means the sign bit 0 does not change, and all the remaining bits are going to move one position to the right. This one is going to fall off, and this place sign bit is going to be filled in, right? So even if you do it one more time, you have to follow the same method. What is it? You have to copy the sign bit, and all the other bits are going to move one bit, right? And again this sign bit is going to be copied. Therefore, as a result of arithmetic right shift, a negative number will remain negative and the positive number will remain positive. Got it? And now if you see this arithmetic left shift and logical left shift both are equivalent. Whatever we did in the logical left shift, same thing happens in the arithmetic left shift as well. Therefore, in many computers we don't have two different hardware circuits implementing these two. In most of the cases we might not even have these two instructions, so they will just provide logical left shift. And so whenever you want to implement even arithmetic left shift, you have to use the same one, because conceptually both are same. So meaning of both these operations is same, and so we don't need two different circuits or two different instructions for this. So in most of the cases only one instruction is going to be enough. Just remember that these two are same and the remaining three are different. Got it? So what is the difficulty? One other difficulty with this instruction is you might have to specify a lot of things here. So see this, what are the various things if you are looking at the operation, right? Let us say every instruction is actually going to be provided as a sequence of bits. In case if the instruction is a shift instruction, then we are supposed to have various parts in it, right? Therefore, if the instruction is a shift instruction, it has to be divided into various parts like this, probably 4 or 5, I think 5 parts. So one is you have to specify the opcode, which means you should say it is a shift operation, right, in some part of the operation. And the next one is you have to even specify the type of the shift. Since you have 4 types of shifts, even though 2 are same, you are supposed to say which one it is. It will take at least 2 bits there, right? And the other one is you have to specify the address or operand. right? So operand is nothing but where is the data that you want to manipulate is present. Got it? And the other one is you have to even specify the count, and you might have to even specify the mode, addressing mode. Therefore the instruction is going to be somewhat big in this case, because along with the operand you are even supposed to say what type it is, shift, and what is the count. So along with this you are supposed to say all this. That is why the instruction of this is going to be a bit lengthy. And next one is rotate right, rotate left. So these operations are simple. Now the next one is coming to the next one. It is rotate right and rotate left. So by the name itself we can know shift means we are going to shift the bits and one of the bit is going to fall off. When you are talking about the rotate, we are not actually shifting them, we are rotating them in such a way that if a bit is going to fall off from one end, it is going to enter the register from the other end. Now let's take the example for this one. Rotate right. Let us say 0 1. Okay, and if I want to rotate right, actually shift right means this bit is going to fall off and all of them are going to move that side. Rotate right is nothing but we have to take this bit and this bit will enter from here and all the bits will adjust simultaneously in such a way that no bits are actually lost but all their positions are shifted one right except the last one, right? Therefore what happens here, this bit is going to come here and all the other bits are going to move one towards the right. So which means this one is going to move right. Got it? And this one is going to move right. So I am going to copy the entire sequence here. Got it? This bit has entered here, 0 has entered here, and all the remaining bits have shifted one bit to the right, which means all the 7 bits I am copying them as it is just by shifting one bit to the right. 1 0 1 0 0 0 1. Got it? And similarly you can even think about rotate left also. So this one is rotate right, and what about rotate right? This one, right? So which means when you look at rotate right, the leftmost this bit has to fall off, but since it is rotate, I'm going to take this one and I'm going to enter it from here. So which means this bit is going to enter here, right? And all the 7 bits are going to shift one position to the left. So here it is going to be 0 1 0 0 0 1 0. So this is rotate left. So rotate right we have seen and rotate left we have seen. Now the next one is rotate right through carry and rotate left through carry. So the main difference between rotate and this new type of rotation is we are going to append one more bit, that is nothing but the carry flag, right? Assume that carry flag is having a bit 1. Now you can think of it not as a 8-bit register, you have to think of it as if it is a 9-bit register and just join them. Take the carry and append it here and you do exactly the same rotation. Got it? So which means if you are trying to rotate right, the rightmost bit is going to fall off, right? So you have to take this rightmost bit and you have to enter it here, and you have to shift all the remaining bits to one position right. From here to here you have to move them one position to the right. Got it? And rotate left means this bit is going to fall off, right? This bit has to fall off and all of them have to move, but since it is rotation you have to take this and enter it from here, and all the bits and all these bits have to move one position to the left. That is through carry. Through carry is nothing but we are also going to have, along with the register, we are going to have a carry bit, and in that carry bit we are going to move the bits. Got it? So this is all about the shift operation.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into university is better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.